domain and the range of graphs. And mostly pretty much doing that all without your calculator. So what do I need you to know at a pretty quick recall? Okay, let's talk about domain first. I find it easiest to do domain to know the exceptions. All right, so when worst comes to worst, what do people put down for domain if they don't know what it is? Okay, right. So, and that's usually the right answer a lot of times. I mean, for like 90% of the functions, that's going to be true. So I say just learn the times when it's not going to be true, okay? And there are only 3 times when that is not going to be the case. All right, so the exceptions are, the first one are even radicals. So, for example, square roots, 4th roots, 8th roots, 6th roots, anything even. That is not the case. Okay? Well, what do you do if it's an even radical? Well, then the domain is greater than or equal to a, and a is the number, whatever's in the radical. That's the first exception, where it's not all real numbers. The second is any kind of logarithm. Natural logarithms, logarithms of common base 10, any kind of logarithm. That's the other time where it's not all real numbers. Well, what do you do with that? Well, the domain of that is greater than a without the equal to part. And the third time, okay, so basically this like has to do with the commandments of math. The first one, thou shalt not square root a negative number. Okay, so that's even radicals. Second one, thou shalt not take the logarithm of a negative number. Okay, third one, what else should you never do in math? You should never divide by 0. Okay, that's the third one, exactly. So anything with a denominator. And if you got a denominator, then you take your domain, and it's going to be not equal to a. Those are the only 3 exceptions. Okay, if the function has an even radical, if the function has a logarithm, if the function has a denominator. If it doesn't have one of those 3 things, then yes, all real numbers is the answer. So if you know those things, then you know how to do domain and range. Just look for the exceptions rather than trying to memorize everything else. So we'll do some samples of that right now. Okay, so I should be able to ask you to give you, any number of functions and have you be able to tell me what the domain is. So the first one, let's say square root x minus 2. Okay, second one, natural log of x plus 5. Third one, tangent of 1 over x plus 1. That's going to be too complicated. Let's just make it tangent of x, and then we'll do p of x, and we'll do 1 over x plus 1 right there. Okay, so these all are exceptions. None of these are all real numbers because they all break one of the rules. So for the first one, it's an even radical. So you can kind of look at your cheat sheet and say, oh, the even radical is the domain has to be something greater than or equal to a. And so you find that by taking the x minus 2 and setting it greater than or equal to 0 for starters. And then you add 2 to both sides. So it's x greater than or equal to 2. So that's the domain. In order to not break the rule of math that says you can't square root a negative number, you only can use numbers greater than or equal to 2. The natural log one, okay, another one that has a rule. And so you would start with x plus 5 because it's a logarithm. It's only greater than. It's not greater than or equal to. And so subtract 5 from both sides. So the domain is x greater than negative 5, but not equal to. Okay, why does tan break the rule? What rule is it breaking, do you think? Well, it doesn't have an even root, doesn't have a logarithm. Does tan have a denominator? Okay, what's the denominator of tan? Exactly, cosine. Okay, it's sine over cosine, so it has a denominator. Okay, so then the denominator is cosine. That can't be equal to 0. So if you remember your rules of cosine, cosine hits 0 around the unit circle a couple times. At pi over 2, at 3 pi over 2, at 5 pi over 2, etc. So x can't be those things. And the bottom one's pretty easy. You see the denominator right away. So x plus 1 can't be equal to 0. So then solve that. X can't be equal to negative 1. So those are some quick ways of how to do domain, just based on knowing the rules. Okay, so that's how you're going to do domain. You don't need a graph to do that. You just need to know the 3 exceptions to when domain's not going to be all real numbers. All right, number 2, range. For this class, you're always going to get the range off the graph. You're going to check the minimum of the graph. You're going to check the maximum of the graph. Now, by checking a graph, I don't mean check a graphing calculator. Those are 2 different things. You need to know what the graph looks like in your head so that you can check it mentally and know what the max or the min is. And so the range would get set whatever the min of the graph is, gets put less than y, and whatever the max of the graph is, gets put greater than y. So you've got to know what the graph looks like and if it's got a minimum or a maximum. So for example, we might do an easy one like x squared, and we might do another one like x cubed minus 1. So I would expect that you know kind of what that looks like mentally without having to check a graphing calculator. You know that x squared is a parabola, and the lowest part of the parabola is where on that graph? On the origin, right? That's the minimum. So the minimum is 0. And then the maximum of the parabola, because it's heading towards infinity, is infinity. Now you don't have to write the infinity part. You can, I mean, if you want to, it's fine. But if you just write y has to be greater than 0, that's fine too. Okay, both of those are equivalent. Okay, a cubic. Can you picture a cubic in your head? I always call it the snake, right? What's the key point that that cubic function always will go through? Same thing the parabola went through. The origin, right? It's going to come up like this, it's going to hit the origin, and it's going to head off. Except, what does this minus 1 do? Just bumps it down 1. Okay, it doesn't matter. You picture that in your head, but what's the minimum? There is none, negative infinity. What's the maximum? Positive infinity. So you could write negative infinity to positive infinity, and I would give you that would be totally perfect. You could write that as an interval, or you could call that all real numbers because that's what negative infinity to positive infinity is. But the range is always going to come from what you know about your graph. Okay, so that leads us now to switch over to our graph paper. And these are some of the graphs you need to be able to sketch. I do not mean like pinpoint accuracy, lots of perfect things, but to sketch. So we're going to switch over to our graph.